We'll now be continuing with IUPAC nomenclature and we'll be carrying on from the previous video. Okay, in the previous video, we have discussed the word root and the secondary suffix and the various, word roots for the number of carbon atoms and the secondary suffixes for the functional groups. Now we're done with that. So now let's come to the basic, process of the naming. So first of all, there are some steps we need to follow, right? There are some steps we need to follow while naming the carbon atom, the organic compound. But the first main step is to identify the parent chain. That is the most important step while the naming of organic compounds. Identify the parent chain. That means you have to identify that chain of carbon atoms which has the most number of carbon atoms. That is chain of carbon atoms with most number of carbon atoms. With most number of carbon atoms. Okay, that's the first thing you need to do. You need to identify the parent chain, that is the chain of carbon atoms with the most number of carbon atoms, right? So let's take an example and go step by step, right? Try to understand it. Let me take the example of, CH3, CH2OH, right? Let's take this example. So this is an alcohol with two carbon atoms. So let's draw the structural formula first. That's what you should do, right? So you can draw it in a compressed form like this: CH3, CH2, OH. So instead of, drawing all the hydrogen attachments and covalent bonds, you can draw it like this in a compressed form. So we're going to identify the parent chain. So it's pretty much easy to identify a parent chain here. This is the only one parent chain, right? That's the most number of carbon atoms. There's one thing to be noted, that when you have a functional group, it is imperative that in the parent chain you need to have the carbon attached to the functional group, right? When there is a functional group, it is imperative that you select the carbon, that kind of parent chain in which the carbon attached to the functional group also gets included in the parent chain, like what we've done here. So CH3, CH2, OH, this carbon is attached to OH. It's imperative that we take this carbon, right? Even if it's not the longest parent chain, sometimes that happens. It's not the longest chain, it's not the chain with the most number of carbon atoms, but you need to choose that carbon that is attached to the functional group if a functional group is present. Okay, so we have selected this, right? That's the first step. We're done with the first step. That's identification of the parent chain. The second step you need to follow is numbering of parent chain. Okay, numbering of parent chain. Now the numbering of parent chain needs to be done, right? And this numbering of parent chain is dependent on the type of hydrocarbon you have. Okay, now it depends on, you number the parent chain in a way which according to the type of the hydrocarbon. So number one, if it is a branched hydrocarbon, because if it's a straight hydrocarbon, then there's no problem, right? If it's a straight open chain hydrocarbon, no branch, then it's pretty much easy. You just number the hydrocarbons. That is, you number the carbons very, very easily, no problem at all. Like for example, if you have carbon, 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 that's it. There's no chain. So just name it like this. You select this chain and 1, 2, 3, 4, 5. That's it, right? There's nothing much to do. But if there is a branch, then you need to do something. So for branch chain hydrocarbons, we number the parent chain in such a way, that what do we say now? In such a way that the carbon attached to the substituent gets the lowest possible number. Right? So let's take an example. For example, carbon, 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 and to this you attach a carbon. So first of all, identify the parent chain. You can do that easily. This is the longest chain, right? So this is the parent chain. And now you number the chain. So there are two ways in which you can number this chain. You can number it like this, starting from here. So 1, 2, 3, 4, right? And then you can number it from right to left also. So you can number it like this as well. 1, 2, 3, 4. Now, as per this rule, this carbon attached to the substituent needs to get the lowest possible number. And it's getting the lowest possible number when we go from right to left. Hence, we number from right to left. Right? So that's how we number the parent chain. And that's clear. So that's with your branch chain hydrocarbon. The next thing you can get is hydrocarbon with functional group. Hydrocarbon with functional group. Now, hydrocarbon with functional group, it's pretty simple. As I've told you, we give preference to the carbon attached to the functional group. Again, that lowest possible number rule will apply. So, number the chain in such a way that the carbon attached to the functional group gets the lowest possible number. Right? So let's take our example of that alcohol we are taking, right? So let's take that same example. We had CH3, CH2, OH, and we have selected this two carbons as the parent chain. Now again, there are two ways in which I can name this parent chain, number this parent chain. Either we can do 1 and 2, or either we can do 1 and 2, from left to right or right to left. But again, we need to give the lowest possible number to the carbon which is attached to the functional group, right? So this carbon should get that preference. So we have to take from right to left, number it like that, right? So I hope that's clear. We have to give the lowest possible number to the carbon which is attached to the functional group. Other than this, we have the third kind of hydrocarbon, that is hydrocarbon with double or triple bond. Hydrocarbon with double or triple bond. Double or triple bond. Okay? Double or triple bond. So if a hydrocarbon has a double or triple bond, then we give the lowest possible preference to the carbon atoms which are linked in that double or triple bond. So number the chain in such a way that the carbon atoms linked in a double or triple bond, you can take notes of this if you wish, in a double or triple bond, get the lowest possible numbers. Okay, so that's what we need to do as well. For example, we have carbon, carbon, double bond, carbon, 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 right? Like this. It's not asymmetric, it's an asymmetric hydrocarbon because there are not equal number of carbon atoms on the two sides of the double bond. So here you can see, first you can identify the parent chain, blah blah blah, that you can all do. But now comes the numbering. So here we go either like this, 1, 2, 3, 4, 5, but here it's getting 3 and 4. And we can do it either like this, 1, 2, 3, 4, 5. So you can see in the first case, from left to right, it gets the lowest possible number, right? 2 and 3. And if you go from right to left, it gets 4 and 3. So obviously we don't want that, right? So 2 and 3. Hence, we number it from left to right because we need to give it the lowest possible number. Right, so I hope that's clear too. Double or triple bonds are also clear. Right, so that's how we can number the parent chain. That's how we number the parent chain of a hydrocarbon after its identification. Okay, so once that's done, I think we're pretty much done with the nomenclature, right? Once that's done, the third step which you need to do is, place the prefix, if any, with the number of the carbon to which the prefix is attached, to which the substituent is attached, and, or you can say directly, followed by its name, followed by the name of the substituent. Usually the substituent is something what we call an alkyl group. Okay, an alkyl group. Usually substituents are alkyl groups. Usually it's an alkyl group. An alkyl group is basically a group which is formed by the removal of a hydrogen from an alkane. So basically, if an alkane loses one hydrogen, it gets an alkyl. For example, methane CH4 loses one hydrogen and forms methyl, okay, which is CH3, okay, and can form another bond, hence it's a substituent. Similarly, ethane lose one hydrogen, ethyl, propane lose one hydrogen, propyl, right? So in this way an alkyl group is formed, and usually that's what we do. So if you have a carbon like this, for example, if you have a chain like this, and to this I'm attaching the carbon, a methyl group here, right? So now we have to name the, first of all, identify the parent chain. So you can do that, it's pretty simple. This is my parent chain, right? Then number the parent chain. Well, this should get the lowest possible number because it has the substituent attached. So 1, 2, 3, 4 and 5. Okay, and now how do we name it? Well, how many carbon atoms are there in the parent chain? 5. So what will be my word root? My word root will be depending on the number of carbon atoms I have in my parent chain. So the word root, since there are 5 carbon atoms, it will be pent. Hence I was telling you, please remember the word roots and substituents and names and the secondary suffixes because they're important. So word root will be pent, and the substituent is attached to the second carbon, right? So what will be my prefix? My prefix will be the number to which it is attached, that is 2, number of the carbon, 2, followed by a dash, and then the name of the substituent, that is the name of the substituent, right? So what is the name of the substituent? Methyl. So 2-methyl, right? If there would have been a carbon like this attached, for example, let's take another case. If there was something attached to this as well, like here CH3, right? Then what would be the case? Can you guess? Then the numbering would be different. Then the numbering would be like this: 1, 2, 3, 4, 5, right? Because they are the lowest root, right? They are the lowest possible numbers given to them. And you can take the sum. 4 plus 1, that is 5, which is obviously less than 2 plus 5, which is 7. You need to look at the lowest possible sum rule then. If there are 2 substituents attached, you need to check the sum of the number of the carbons, the number the carbons are getting, and then take their sum. The lowest sum, that's how you have to number it. Okay, so you number it like this then. And then in this case, if it's attached like this, then the prefix will be 1,4, because both 1 and 4 have a substituent. 1,4 dimethyl, because there are 2 methyl groups attached, right? So 1,4 dimethyl. If there are 3, then accordingly the 3 numbers, and if 2 are attached to 1 carbon atom, then you put 1,1. So number of that carbon atom 2 times, 2,2 or whatever, repetitive, and then di or whatever, try whatever you want to do. Okay, so word root, let's come back to our normal case. Word root will be pent, prefix will be 2-methyl, and you know that it is an alkane, there is only single bond, so you can say that primary suffix will be ane, and there will be no secondary suffix since there is no functional group. So ultimately the name of this compound, if you go by the structure, it is 2-methyl plus pent plus ane, you will get 2-methyl pentane. This is the name of this organic compound, 2-methyl pentane. Okay, just ignore the substituent. The substituent is not there originally. Okay, fine. So we are looking into the original group. So alkyl group is usually the substituent, and if there's a substituent, this is how you have to name. First the word root, that is the number of carbon, depending on the number of carbon atoms in the parent chain, then the prefix, and then the primary suffix. Right? It can be ene as well. There can be double bond as well as a substituent. Right? So you should be careful. Now let us look at our case again when we have a functional group attached. So let us look back to our case of that alcohol CH3CH2OH, and we had identified the parent chain, and then we had numbered it as well, right? Like this, 1 and then 2. So now this one has attached this thing. So first, what's the word root? Can you get the word root? Yes, there are 2 carbon atoms in the parent chain, so the word root will be eth. Very good. Let's look at the prefix. Is there any prefix? No, there is no prefix because there is no substituent attached and there is no halo group. Next comes the primary suffix, which is ane, because all are single bonds, and then secondary suffix, which will be present this time because there is a functional group, that is all. And here too you need to make sure that the carbon, actually you should write it like 1 all, right? Because it is attached to the first number 1 carbon atom, right? Because if it would have been attached to some other carbon atom with 2, 3, 4 number, then you write 2 all, 3 all, 4 all, etc. Okay, but it's attached to the first carbon atom, so we usually don't write 1, we just write all. Okay, that in general. So again, let's write the name now. So the name will be the prefix plus the word root plus primary suffix plus secondary suffix plus this no prefix. So we directly start from the word root. Eth plus ane plus all. Now when we are adding this E gets removed. Basically, when we are writing with functional group, this E gets removed and we get ethanol, which is the IUPAC name of this compound. Clear? I hope that's absolutely clear to all of you, right? Let's take another example with another kind of functional group. Let's take a functional group like CH3, C double bond O, CH3, sorry, not CH3, CH2, CH3. Right? So let's have a look at this compound. First of all, identify the parent chain. That's the first step. So obviously, very clearly you can say that this is the parent chain. Right? Now number it in such a way that the carbon attached to the functional group is the lowest possible number. So this can get either like this 2 or like this 3. So obviously you should get 2. 1, 2, 3, 4 because it has to get the lowest possible number. So this 2. Now let's just write down our data. Word root is bute because there are 4 carbon atoms. So bute. Prefix none, obviously because there's no substituent. Primary suffix all single bonds, so ane. Secondary suffix, what kind of functional group do we have? It is a ketone, so it will be 2-one. This time it will be 2-one. Why 2-one? Because it is attached to the carbon atom with the number 2, so 2-one. Now we write the name of this compound, so it is, let's write the name. The name will be bute plus ane plus one. So this E gets cancelled here and you will get butanone. But is it one? No, it is 2-one. It is 2-one. So you ultimately get butane 2-one. Right? That's absolutely clear. Now let's take one more last example with a multiple bond, right? So for example, we have CH3, CH double bond, CH2, right? So suppose this is the carbon, this is the thing. Now let's select the parent chain. Obviously this is pretty simple to understand. There's one direct parent chain, right, with 3 carbon atoms. Now how do we number this? Again, the lowest possible numbers. So 1, 2, 3, right? Now word root. So word root is prop Prefix is nothing because there's no substituent. Primary suffix. Now comes the confusion. Should we put "-ene" or should we put "-ene"? Because both carbon atoms are involved, right? So should we put "-ene", that is one "-ene", or should we put "-ene"? Remember this one thing, whenever we are putting that "-ene" or whenever we are putting that number, we have to put the lowest number. So the lowest number from whichever carbons are attached in the bond. So in the multiple bond, the carbons which are involved in the multiple bond, you need to put out of them the lowest number, right? So out of 2 and 1, the lowest number is 1. That is why we put 1-ene. We don't put 2-ene because we have to put the lowest possible number. So 1-ene. And secondary suffix will be nothing because there's no functional group. So the name of this compound, if you want to write the name of this compound, now you can do that. So prop plus 1-ene, or you can simply write "-ene", and there's nothing, it's directly propene. Right? Same can be done with propyne or any other triple bond or any other double bond compound. Right? So I hope everything in IUPAC nomenclature is clear. Right? Let's take another example for halo group so that it gets really clear for you. So suppose there is a halo group. There is F attached to CH2, attached to CH2, attached to CH2, attached to OH. Now this is a good compound because there are two functional groups, a halo group as well as a hydroxyl group. So first of all, identify the carbon atoms. You have to identify this. So this is the carbon atoms. This is the parent chain. Now how do we number the parent chain? How do we number the parent chain? Because there are two kinds of functional groups, right? Now understand there is a particular hierarchy we follow, right? There is a hierarchy of naming, hierarchy of priority of functional groups, in which this halo group occupies a very less space as compared to hydroxyl group. So always we give preference to hydroxyl group over the halo group. So it should get the lowest possible number. Now that's clear. There's a hierarchy of compounds which you can check out on the net. You can find that there is a hierarchy of priority for functional groups. Okay, that's what we are following here. So after that numbering is done, we are giving preference to OH, and that's the numbering is done. So we have word root, which is prop. Again, there are 3 carbon atoms in the parent chain. That's why. Prefix. Will there be a prefix? Yes, there will be a prefix. It is 3-fluoro. Right? 3-fluoro. Can you guess that? Yes, because it's fluorine halo group or fluoro halo group attached to the 3rd carbon atom. Prefix, then primary suffix will be "-ene. Secondary suffix will be "-all". So now you put the name of this compound, which is easy now. So the name of the compound will be prop. No, not prop. We have a prefix this time. So 3-fluoro plus prop plus "-ene plus "-all". And this E gets cancelled. You will have 3-fluoropropanol. This is the name of this compound. I hope IUPAC nomenclature is clear for all of you. Any doubts are welcome in the comment section below, and it's imperative that you get this clear because it is an important concept. Thank you very much for joining me, and now from the next video we'll be beginning organic reactions. Thank you very much.